Okay, guys, welcome to another episode of CUDA Education. Today, we are going to dive into the modern renderer application for Apple Metal. So, this is Apple Metal 4 modern renderer application. It's freely available online. You could download it, all that good stuff. Um, it's the modern renderer example sample code for Apple Metal. And basically, this is our application, right? So we want to start the engine and get our hands dirty with how this application works, right? So you guys, what I want to do, right? So you guys could see that this is the application here, right? And we could move forward, we could move backward, move side to side, all of that good stuff, right? So this is our application, right? So one of the things that I want to one of the things that we're gonna start is we're in the renderer. So modern renderer AAPL renderer.m file, and we are in the draw in MTK view. Now you guys know, if you've been rocking with this channel, what the draw in MTK view is. It's basically, the main function that sort of, deals with displaying things and all that good stuff, right? So one of the first things that happens is that we have we set up a semaphore, a wait semaphore, dispatch semaphore wait. So we set up a wait semaphore so that we set up a wait semaphore so that there is no stepping on toes between synchronization. Okay, so um, so basically what happens is that we have a wait semaphore that just deals with making sure that the frames are dealt with properly before we between the CPU and GPU. Now, what I'm going to attempt to do is I'm going to attempt to hack this particular situation. So we have dispatch wait semaphore and in-flight semaphore, right? So we have about 3 frames that we're dealing with, and we're trying to we're trying to basically use those 3 frames to handle building each frame, and then presenting to the screen. Okay, and we use 3 frames in order to do that. So while one frame is being presented to the screen, another of the other 2 remaining frames is being worked on, let's say by the CPU, so that instructions and everything can be processed properly and drawn and all that stuff, or at least the calls for the frame can be submitted, and it can be worked on so that it can be prepared to be presented to the screen, right? So we have sort of a buffer or a spacing of 3 frames, right? So while one frame is presented, the other 2 is not is being worked on. Now I want to be careful. I want to be careful with the words that I'm using here, because this semaphore thing might have a different meaning in Apple Metal world than it does in Vulkan world. There might be a subtle difference in the word, right? But let's for the time being, let's just run with dispatch semaphore wait is dealing with synchronization. It might be CPU GPU synchronization, but we're dealing with synchronization. But what we can what we can do is we could play around with this. So first of all, we have this wait thing, and then notice that we're managing these max frames in flight. Okay, so let us go to Codex. Let us go to Codex, and we want to know. We know that it's 3 frames that we're dealing with, but we're gonna hack this system now, right? So we want to know where is the max frames in flight variable set in this application, right? So I'm asking Codex, which is the AI model from ChatGPT for programming and coding. I'm going to ask it to tell me where this variable is set in this modern renderer application. Now, if you guys are interested in running this, to having the Codex run on your machine, you need to make sure you have the latest Mac OS operating system. You need to make sure that you have Xcode 26.3. Now, as of the creation of this video, Xcode 26.2 is what is in the App Store. So 26.2 is in the App Store. In order for you to get 26.3, as of the making of this video, as of today, you have to get a free Apple developer account. You have to sign up for a free Apple developer account, log into the Apple developer portal, and then download the beta release, the release candidate, Xcode 26.3. Xcode 26.3. This whole interface and everything, it only works with Xcode 26.3, but it's in the Apple developer portal, the beta release candidate, Xcode 26.3. You have to download that, install that on your system. And then once you're in there, once you open up Xcode with whatever project, you press this star thing, this will open up, and then it will ask you to choose whether you want to use Claude, which is the Anthropic AI model provider, or Codex, which is the ChatGPT AI model provider. There's also the ability to add in other providers. So, for example, if you want Gemini, you could add in a key and all that stuff in order to get it going. Now, the thing with Codex is that you have to be a paid subscriber to ChatGPT in order to run Codex on your system, right? To have Codex on your system, you have to be a paid ChatGPT member and all that stuff, right? So anyway, I say that to say this. So we open up, we press this star thing, and then I know where the file is, sort of, but I just want to demonstrate. So we're gonna ask it now to find where is this variable set, because we're gonna play around with it and see how synchronization gets screwed up. So defined as a macro in modern renderer APL config H and line 81. So I'll just do it the basic way. So renderer, so it's AAPL config.h. This is the H, right? So we go to that, and then we go down to line 81, which I'm already here, and we're already at 3 frames per second. Okay, I mean, we're already at three frames that we're working with, right? So what I'm gonna do now is, instead of working with 3 frames where triple buffering, CPU writes constants, GPU begins reading them, right? You have that CPU GPU dynamic where the CPU is submitting stuff and working on frames, and the GPU is presenting to the screen, right? And actually doing the commands and presenting to the screen. Now, what we're gonna do is we're gonna mess around. We're gonna mess around with this thing. First thing we're gonna do actually is we're gonna disable this waiting. So we're gonna disable this ability to wait. So there is proper synchronization between CPU and GPU. We're disabling dispatch semaphore wait. Okay, so we're disabling synchronization, right? So sort of, you know, things are just going to be running as fast as they can. Now, what happens is that the CPU can submit stuff faster than the GPU can process stuff, right? Just because all the CPU doing is submitting instructions, right? So we're disabling the ability. So don't start working on this frame because it's currently being presented to the screen. That's what the weight is for the CPU side, right? Don't mess around with this frame because it's being used by the GPU to present to the screen, right? So we're gonna disable that synchronization, and we're just gonna have CPU submitting stuff and GPU presenting whatever whatever it has, right? And the CPU is not waiting on the GPU, and the GPU is not waiting on the CPU, and there's no synchronization. So we're going to disable this synchronization, and then also what we're going to do is we're going to take out, instead of 3 frames that we're working with, we are only going to be working with 1 frame, right? So not only are we disabling synchronization, but we're also we're collapsing the number of frames that the basically the CPU and GPU can play with, right? And when you do this, very bad things happen. So we'll see right now when we run this code, we're gonna see that I gotta make sure all my things are saved, right? We're gonna see that we disable synchronization, and then we also collapse the number of frames that the application can work with. We're only dealing with 1 frame. So CPU is doing stuff, GPU is doing stuff, and we're only doing 1 frame. So when we run the application now, we are gonna see that. So the build succeeded, and we could see now that things get really bad, right? It's almost like a horror story now. So we're in a horror movie, guys. It's no longer just a rendering. Now it's like horror modern rendering. But we could see here where there is corruption going on, right? Flickering and corruption, and that makes sense because we disabled synchronization, and we also disabled synchronization, and we also disabled we collapsed the number of frames that we are working with. Now the thing about it is that let us keep only 1 frame, but we're going to introduce back into the picture synchronization. So we're putting back in synchronization now. Let's see what happens when we put back in synchronization. Okay, so when we put back in synchronization, notice that we basically get back what we had before. It is a little bit stuttery. I think so, right? It's a little bit stuttery, right? But that's what happens when we put back in synchronization. Now, let's say we take back out synchronization, but then we increase the number of frames that we have, right? So we do two frames that we're working with, right? When we do that, even though we took out synchronization, we'll see that we don't have synchronization, but we have 2 frames. So we see that things get a little bit more reasonable, right? It's still not smooth and perfect, but you still kind of see some stuttering when we move the camera. But we do see an improvement, right? If we do 3 frames, we might see a better improvement again, just because now we have 3 frames to work with, right? So we're gonna see. All right, we still see a little bit of a stuttering, right? Because we don't have the synchronization, okay? But it's not even that much improved. It's still a little bit, So then now let's do 2 frames. We're gonna do 2 frames, but we're gonna introduce in back synchronization, okay? So dispatch semaphore wait, right? We're gonna introduced back in this particular command so that we get okay, we get a little bit better, right? You know, it is what it is, right? But when we do 3 frames now, we should be all good to go, right? Things should run cleanly, right? And we should be good to go. All right, so we're basically, we still have that little screen thing, but you know, we're in good shape, right? You know, we're in good shape. Let's do, I don't know if this will make a difference, 30 frames per second. I don't know if that's probably not gonna change much. I mean 30 max frames in flight, sorry. 30 max frames in flight. I guess at that point it doesn't make a difference, right? I mean, you really only need 3 frames, you know, to do what you need to do. But that's the lesson, guys. Now let's do 3 frames. Let's do 3 frames where we take out dispatch. I believe we're still good, right? We're still good. We're still good, right? So anyway, guys, just so you guys know, let's just do this one more time. So we're gonna collapse this back to 1. Flicker warning, guys. Flicker warning. Flicker warning. Flicker warning. Flicker warning. Flicker warning. So once we have synchronization, things calm down to what they need to be, right? So there you have it, guys. There you have it. So that's the lesson for today, guys. So you know, we're in the draw in MTK view. So we're in the view window. We now know that synchronization, dispatch, semaphore wait. Synchronization is a very important thing because it allows us to make sure that things run properly, and we also have max frames in flight. And we also have our little helper function here, dispatch wait, semaphore wait. So I'm going to ask Codex, what is this guy? And Codex is going to tell me is a Grand Central dispatch function that decrements a semaphore or blocks the current thread until the semaphore is signaled or a timeout occurs. It's used to limit how many frames or tasks can be in flight concurrently. Is dispatch a process that syncs between 2 GPU processes, or does it sync between CPU and GPU processes also? The reason I ask this is because in Vulkan I know that semaphores are GPU synchronization. So it's 2 GPU processes that you're trying to sync up and make sure they don't step on each other's toes. But that's in Vulkan. I don't know if in Metal, in Apple Metal, this word semaphore means the same thing. Is a process that syncs between 2 GPU, or does it sync between also? I need to make sure I understand what the word semaphore means in Apple Metal 4. So we're gonna ask Codex, what does dispatch CPU semaphore wait is a CPU side GCD semaphore. It blocks the calling thread until another CPU thread signals a semaphore or a timeout. It does not synchronize GPU work directly. In this metal sample, it's used to cap the number of frames in flight on the CPU. The semaphore is typically signaled from a command buffer completion handler, still CPU, which indirectly gates how much work the CPU can enqueue ahead of the GPU. So for GPU CPU or GPU GPU synchronization in metal, use metal primitives like MTL command buffer completion handlers or wait until completed. CPU waits for GPU. So that wait until completed is CPU waits for GPU. There's MTL shared event or MTL shared event listener, CPU GPU signaling. And then there's MTL fence, GPU within a command queue. GPU, I guess, synchronization within a command queue. So semaphore here means a classic CPU concurrency primitive, not a GPU sync object. Okay? So now I'm just totally confused because Vulkan, it's almost like the opposite. Okay? But here in metal, semaphore means CPU concurrency primitive. So I hope I don't confuse you guys with me switching between Vulkan and metal. But here in metal world, semaphore is CPU, generally CPU synchronization. So it's doing it indirectly because the CPU, it blocks the calling thread until CPU thread signals a semaphore or timeout. It does not synchronize GPU work directly. Okay, so there you have it, guys. Dispatch semaphore wait. I'm gonna have to put I'm gonna have to investigate this stuff more. And then when you're done with Codex, you basically just press the button and you're out of it. Okay, but there you have it, guys. That's all I wanted to cover today. Drawing MTK view. We have discussed this before. This is CUDA Education. Like, subscribe, tell your friends. Get anyone that's interested in computer graphics on the Apple ecosystem to follow and join in on the fun. I'm going to be spending my time in 2026 learning Apple Metal. So thank you guys for watching. Have a great day.